Vamos a
Thank
hacerlo
you,
así
Miss.
mejor, porque sí, ahorita voy a explicar algunas cosas que vienen en el examen, entonces así ustedes van
Sí.
a quedar más
Pero
claros y se los
igual,
voy a subir.
igual es hasta las 6. O sea, vamos
Sí,
a estar hasta las 6. Gracias, Miss.
excelente. Bueno, gracias que me avisó. Y bueno, la clase la vamos a concluir entonces ya el próximo fin de semana con las clases simuladas. Al final les voy a mostrar el horario, pero sí les voy a pedir, por favor, si no han podido trabajar en lo del el planning, vayan terminándolo. Mañana tenemos una pequeña sesión. Esa sesión va a ser para pulir detalles, por eso dura menos, solo dura media hora. Yo espero empiecen a compartir los links nuevamente. Así como la fin de semana pasado, que como les decía al inicio, o sea, muchos equipos ya, incluso algunos tienen sus videos tutoriales hechos y eso es excelente. Ya los pueden ir compartiendo en el espacio ahí porque la actividad de los videos tutoriales no termina solo en compartir, ¿verdad? Ya les voy a explicar yo al final. Pero bueno, estoy hablando de muchas cosas, mejor centrémonos en lo de ahorita. Like I was saying, sorry, better in English. We're going to focus right now on this first presentation about the methodologies to teach mathematics. We have been talking about some of these ones. I have been watching in your planning, your focus a lot and a little bit in problem solving, I think so, and that's so good. And we will see then what are the elements we have to consider on this. So remember this theory will come on test. It's something that I will evaluate over. Okay, so let's start with this presentation. Okay, so good afternoon, everybody. Nice to see you again. We're going to start with this class today talking about some methodologies to teach math. Some of these ones, okay, and the ones that I think we have to try to focus a lot because are the ones that are showing very good results. So we have some math methodologies, the ones that we normally, or with the ones we learn, I think, the repetition model, for example, or the time testing are two very old school methodologies. So those traditional methodologies to teach mathematics are very systematic. They are very rude in the sense that they look just for the memorization, and that's a problem. Just follow some established steps to get an answer. Students memorize rules, memorize process, memorize the table of 1, 2, 3, and 4. And at the end, well, this is not what we want in math. Just a little help. Who's the user whose name is elementary school? Oh, she or he left. Okay. So into what conclude this? It concludes into the imposition of logic, not the developing of logic, an imposition of logic. Why? Because we don't let students think. Just gave them everything, and well, what we do essentially with these traditional methodologies is think for the students, not let them think. Okay, so in those passing decades, and I'm talking from 60s until today, there are many systems of learning that have been in evolution and start to create very good models and very good methodologies that we will try to explore today and see what are the elements we have to work in here. So in 1960, we were with mathematics as a dogmatic mathematics, which is something that um, we gave the students the chance. I mean, we don't give the students the chance to explore one content of math. It's not like today that we have games. Today we have concrete materials, different many activities. All those have been growing. All those ideas and didactics elements have been growing since the 60s, the 1960s, 60 years ago, practically. So some methodologies we will explore today. The ABN normally is called like open based on numbers algorithm, or like I call it, algorithm based on numbers, which is practically the same. The TWL, the think without limits, is not just for math. And this is related with the Singapore method. I think, I don't remember, was Alejandro Godoy who told me you were working with this methodology. I think so. So you can probably see some of the things you do in your classes here. And finally, problem solving as like the one our curricula is asking us to apply. So let's explore each of these methodologies, starting with the ABM. This methodology responds to an important area of mathematics and practically is the base of everything. It's the base of every mathematics we learn later. So this methodology focuses in arithmetics, and if you know, arithmetics is the area of basic operations like addition, subtraction, multiplication, division. So this one works uh, based not in the procedure, it works based on the behavior of numbers and like the techniques that I teach you the last time, or we saw the last time, we explored the last time, where we break the numbers however we want, and we operate in a different way, okay? I will be uploading this presentation to the class, so don't worry if you're like, you want to copy or something. Just like try to take the main ideas, okay, or important elements I will mention. So the interesting about this is that not just teachers, researchers, and psychologists have been working on it, even though the parents, okay, even though dads and students have been working um, in this learning theory, which is very interesting. They have been providing some ideas. For example, I remember last time was giving you classes, the last 2018, I think, yes, in fundamentals. I was telling you that some students in Spain were working or were looking the way just to work any multiplication based on the table of five. They almost get it, but they have to prove many other um, things and what they can do with this idea of multiply by five. Well, it's just an approach of something they will probably discover, still working on it. So good. So 6 decades ago, okay, give me a second. One classmate, want to join? Okay, there he is. 6 decades ago, this mathematical process have been focused in training students into just work with a stable, or how can I say it, with one method, with one algorithm. And this is the algorithm of multiplication. This is the algorithm of addition of decimal numbers, place decimal units above decimal units, the ones above the ones, and so on. So this is something we already know how it works. It's how we learn. But today, how we teach, okay, it have to change a little bit. We have to provide students, according with this methodology, other possible ways to learn, not just this ones. Those are closed algorithms. They're called like that, okay? Those traditional methods we normally use are called closed algorithms, and they are based on the positional system. Second, oh, yes. So the IBM methodology, as a response to this, becomes to be a significant chance into the quantity and the quality of children's mathematical achievement. According to Montero, who's one of the most um, persons or researchers on this ABM methodology, this teaching is based on understanding rather than memorization or memorizing concepts and processes. And it's very interesting because here students breaks apart the idea of just follow one procedure. No, if they're clear with what is a number and how the number behave, wow, they can do whatever they want with those operations. Of course, we will see later that we have to respect like what's the idea behind of the addition, and if you're changing this idea, well, you're not respecting the mathematics behind that. And that's a little problem with this methodology too. So here you have one example, three ways, three students doing an operation in a similar way probably, but in different ways, okay? In different ways. Those ways are similar, but they are not. Just let me check some of the classmates who join right now. Okay, so good. And well, we were exploring some of these ABN techniques in the other class with, for example, multiplying based on pattern. I remember that one group who's gonna work the addition of fraction didn't know about one interesting method using normally to compare fractions. Here you have another way to multiply, for example. And probably, yes, those ABN methods will work faster or not too fast as the other traditional methods we already know. For example, this one is the box method. It's an ABN method. It's an open calculation method because here you break apart the idea of the number. Okay, and essentially you have here another algorithm, another procedure that works based on the behavior of the number, not in the behavior of the positional system. This was created by um, Indians, by Hindu, those peoples in Arabia. And well, yes, and I think you have been hearing about the algebra of Baldor. It's something we already know. And yes, they work a lot mathematics this way, but they have been remaking this and inclusively they propose ideas like this box method. And in England, it's too common to see this box method or this box method technique to multiply. At the end, it's very interesting how a culture can influence to another with something simple like a multiplication. Here it's something I want to share to you, probably something you already use, like the butterfly method, which is very good at the moment to compare fraction, but not just that. It's very useful to add them. We have the problem, especially suppose here between those, there's a plus. And if you want to add them, it is impossible right now because those are not working same denominator. Is it possible to convert those fractions into same denominator fractions without looking for the LCM, which sometimes is very difficult for some students, or sometimes it's something that students get confused? Yeah, here is this method. This is called the butterfly method. I normally use it as a happy face method, okay? And this is what this ABN method proposed. Okay, let's see what happened with this. The awareness of children's different capacities and skills are focused on organizative and procedimental aspect, not in curricular aspects. So this is a little trouble we have with this, and is that we have to be focused not a lot in these curricular results we want to. Okay, we have to focus more in what the students is developed, and it's very hard. It's very hard because we have this like objective or this rule and respond to those standards we have over there. Some principles of the ABN. Okay, follows next principle. The first one is calculation based on numbers. Is not a traditional method because it's not based on traditional algorithms. Are the algorithm accept for the ABN method? Yes, but it's just like one option to do a multiplication and addition, subtraction or division. Remember that this is focused more in arithmetics than in the other area. So that's like another disadvantage about this methodology. Numbers considered from different points of view. Open calculation method, so it requires the appropriation of logical rules because students can create their own method or discover their own method. They don't have to break apart the idea of, for example, the addition. Transparent calculation, that's what I'm saying, not breaking apart the sense of the operation. For example, they cannot say that what they will be subtracting many things. Well, they can do it, no problem, as we saw it in one exercise. Is subtracting in one addition breaking apart the idea of the operation? No, it's just that you're mixing here some other ways to do it. But what's working behind it? That's what we have to have, what we must have clear. What's addition is join things. What's addition other way as the ABN see it? A counting on work. That's an addition for the ABN, and that's why you can play with the numbers as we did it last time and solve one exercise that's working like 100 and leave it like a closed number, like 120 or 150, and add with another one. And this is the idea, right? Of course, this works not in the idea that you're gonna join things. No, because probably you're gonna subtract over there. But it doesn't lose the sense of the operation. Other principle is that it's realistic, estimate, and reference. So what do we develop with this? Accuracy and precision. And accuracy and precision are two soft competences in math. Okay, accuracy and precision, two soft competences in math. Calculation with real problem solving, of course, we want to give a sense to this knowledge, and ABN takes some elements of the problem solving methodology, but ABN at the end focusing many ways to work one exercise. Calculation with estimation and approximation. So what we do with this is promote the mental math. I think it's something you told me last class, so you're clear a little bit with how this method works. So what happened if we want to move this ABN to our classes? It requires open and personalized teaching process because students can solve exercises in several ways, which create to us, the teachers, a little problem. Okay, and that's related with the evaluation. Something that we have clear with the traditional methods is that we will evaluate something one way, not other one, this way. Is it good? Okay, for some areas, that's so good. I mean, is it possible ¿será posible inyectar a una persona de otra forma? Is it possible? I don't know. Do we have doctors here? Hasta duele el brazo solo
You can't, no se puede inyectar de otra manera, porque puede fregar el músculo, y además cada una hay una que es intravenosa y hay una que es muscular.
Y para ponerla intravenosa solo hay una forma, para ponerla muscular solo hay una forma.
Hay otra.
A eso me refiero. Hay cosas que sí solo se pueden hacer de una manera. Entonces, these kind of things, sorry, they can just be done by one way. It's not that they don't fit in the ABN. They fit, but they probably will not work as we expect. So what happened if we move it to the class? Okay, not following specific rules opens the evaluation, not like the curricula proposal. That's a problem. And what happened with us? Okay, we have to promote a new kind of evaluation where we have to focus not in the answers, in the process. And well, it requires then that we becomes to be a specialist in the class we are working, or in this case in math. Inside the classroom, the teacher had to create a community of learners because students share the same learning goal. Well, not just in this methodology, it's something that you have to do in all methodologies, but right now here, this one is like something that is requested. It's something that we have to do. What happened with math? Okay, with math, we have another problem. And this has a little critics about, there are some critics about this one, and is that breaks apart the community perspective of mathematics as a formal and a structured language. Why? Because if we understand mathematics as a universal language or a structured language, we can probably break apart this idea, working an addition in this way, working an addition in this other way. Is that good or bad? Well, it's not bad if the students are learning and understanding. But it's going to be bad then if in society they are not accepted because they add different way than the rest of the people. You have to believe that students have math in their brains. Math is an innate capacity of humans, and sometimes that's a challenge, right? Because for us, sometimes it's difficult to teach math. And like last time you said, we translate our emotions to the students, and have been a taboo. I said the last class that math is hard, math is impossible. It's okay. We have to break apart this idea, and ABN gave us like the tools to do this. Let's go with the next methodology. I'm trying to be faster because there are some other things we want to do. And well, let me check something. It's because I have twice the same person here. Is Mr. Ivan here? It's because I'm checking UR with two devices. Am I right?
Es que se le fue la luz, mister.
Ok, Dios mío. Y sigue con los cortes. Okay, so let's continue. Thank you for telling me. So, teach students to learn master mathematical concept at the greater details while having them to learn these three basic concepts. And normally, TWL methodology works in pre-K and moves on the years. It's not like the ABN. The ABN is something you can apply right now with your students. If you ever use it before, you can use it today, no problem. With the TWL, we have a problem. And is that if we don't start teaching with this methodology, then it will be so hard for students to understand and get how this one works. It's because it's very different. Normally in Asia, students work this way. So here we practically work based in these three steps. And well, to define a number or to create the idea of number, we have to move like from using this idea from the concrete to the pictorial and concluding to the abstraction of this idea or the creation of this idea. Because at the end, numbers are those ideas. It's not like in science. In science, you talk about a tree, and well, you can go outside and see one tree out of the school or a plant or a flower. Okay, but in I mean, we don't have numbers running over there, right? It's not like a safari when we look for numbers. No, it's something that's just an idea that represents a quantity. And that sometimes is so hard. So this methodology provides us like the ideas to do or to create this abstraction in the students. So as you can see here, there's a little example. You go from the concrete, then you translate this to something pictorial, and then the abstraction. Is it needed to do it like this? Yes. Do we have the chance right now to do it like this in the situation we are right now? I don't think that we can do it at all, especially the part of concrete. Why the concrete is so important? Because the students will connect those feelings with that idea. Okay, and that's why this is a little bit hard right now to use in the situation we are. So there are 5 factors of success according with this. The first one is that we must be qualified. Okay, we must be qualified to work with this TWL. Little question: have you ever heard about the bar model technique? Teach mathematics to teach additions, for example, to teach subtractions. Have you ever heard the bar model? Someone? No? Yes? Can you tell me something about it? Okay, not so we will explore this idea. It's so hard to understand that because you have to like forget what you learn about um, the addition and focus then just in like a little bar to solve a problem. It's so interesting. We will see it. Well managed at school. In this case, we're talking about that we need experts. Okay, and then like I told you, TWL is not just for math, but I'm focusing this one in math. So we must have experts like coordinating or bossing or being the boss for the specific areas. Okay, we need what's the word in English? Okay, necesitamos coordinaciones académicas. That's like the word. That's something that TWL requires. Subjective banding, and it's that the curricula must focus in the needs of students' ages. We have this in our curricula. Well, we have it, but we have this for students of 20 years ago, I think. And the students of today, they require something different. So we have to work again in the curricula, and I think it's not something we're doing in our country. The same happens with the other curriculums. I think the only one that have been doing this in those last 5 years, I saw it last time in a document of the NCTM, is the Massachusetts. I think it's the Massachusetts curricula, which is, I think, today the best one. I think so. I don't remember if it's Massachusetts. I think it's that one. So another factor of success is high expectation of the parents, teachers, and students, and it is because this methodology have been growing in those days. And if we listen something about the Singapore method, we will think this is the best one, right? So everybody can learn. Math ability is believed to be more a matter of hard work than an innate ability, which is a little different than the ABN, because in ABN we have to consider students like they have math in their veins. Here, no, here that we see or researchers see that um, mathematics is something they can learn by a hard work. So it's not impossible. What happened with this methodology in mathematics? It promotes the comprehension, good retention of mathematical concepts, solve problems with non-complex strategies like the one I will show you related with these bar models, promotes math basic skills and the enjoyment of math challenges because they will see math like a piece of cake. And this is something good about this. That's why parents expect a lot on this and students too, even the teachers. So what happened if we want to move these to the class? The topics are introduced um, to use the knowledge for challenging problems, challenging situations. We will talk a little bit about problems. Don't think that problems are just those that are reading story problems, I mean. And it is because a situation like the Tangram could be a problem, okay? Could be considered as a problem. Emphasizing mental math skills, and the classroom is a space for experimentation and exploration. No more than a lesson, it's a space for experimentation. So we have to provide students many tools in here, many concrete materials, because that way they will explore. And it's a challenge. It's a big challenge, I think, because in our classroom and in the situation we are right now, concrete material, well, it's something that we cannot see working, but it's something that you should consider for your um, classes when we return to that normality. Probably next year, I think so. I hope so. So teacher work. What about the teacher? Teacher works based on 3 sequence steps. Solving problems with this method. The first one is develop students' good reading abilities, planning of the solution, and accuracy in the answer. So we have to look for this or promote these um, abilities in the students. And this is like part of the work we have to do. Of course, we have to respect students' age to gradually create a knowledge, this this network of knowledge of math, and they will be connecting those their own by using this, solving some challenges. I prefer to call challenges than problems to those exercises that TWL proposed. What will be our work? So guide students to answer word problems through their or knowledge. Check answers. Not It's not that you're gonna tell the answer. No, you're gonna just check answer. Correct, incorrect. That's it. You almost get it. Continue trying. You got it. So it's not that you're gonna provide the answers. We're gonna orientate students to take right decisions. So we're gonna make questions, comparisons, and analogies. Here is, I mean, this require a lot of job from us teachers. So apply this methodology is not something you're gonna do tomorrow with your students. No, it's something that requires years and years of preparation. Permanent formation and innovation proposed by experts. So it is something that coincides with the other method. We require qualified teacher because those models have been growing and growing a lot in those decades, in those last decades. So here's the technique. We have 2 kinds of bar models. One that's called par-hole model, and normally is useful for problems where you have elements that are part of a total, or if you have the total and then you want to get those elements. The other model is comparison bars, and normally here you compare 2 quantities. Here you have an approach of how to work these ones and how these methods work. You see here part whole, those are like variations of those models, but at the end we have those models. Not that we have 5 models, no, it's 2 models separating these different ways. I want to make one activity, so try to answer very quickly, and I want that you identify if next situation Next story problem, it's focused in part whole model or comparison bar. What do you think? Lisa is 13 years old. Her sister is 22 years old. Find the difference in age between them.
Comparison.
It's a comparison.
Yes.
Okay, I agree with you. It's a comparison bar model. And yes, this is the way we solve it. Normally here, the TWL doesn't focus and teach that. Here we have to make a subtraction. They just compare those bars. And for example, to answer the question here, all that students have to do is continue the counting until 22. Understand the idea of that here you have like 13 mini squares is very important, but this is something we have to teach students from first grade, I think. It's so hard to teach these students that are in sixth grade because it breaks apart the idea of math, because here at the end, you're gonna work just with little squares. And what they have to do in this case is complete the amount of, okay, rectangles in this case, to get the 22. And that's going to be the difference. So this is how this methodology works. Again, it's not something we can develop the students like today because it required preparation, right? Required years of preparations. What about next one? What model works for this one? On Tuesday, Colt ran 6 miles. On Thursday, he ran 8 miles. How many miles did he run altogether?
What's the name of the other model?
Okay, let's go back.
Part
Whole and comparison bar. So we were with comparison bar, and yeah, that's part whole. Yes, and especially here you have like a situation breaking two pieces that correspond to the same. In this case, is the amount of miles he ran. And yeah, what principle is behind this? The principle of addition. That's why the bars becomes to be joined. And this model is very interesting. We're gonna try to explore some story problems with one activity I prepared to you. I think it's the most challenging activity because it has many of those story problems, and it is because I want that you try to to see how to solve a story problem. I think you have used to solve those, so we will see what happened with those that are focused in math abilities. And well, here's the last. I think is one of the methodologies we have been listening a lot, we have been practicing a lot, and it's so good because it's in our curriculum. It's part of our curriculum. Teach mathematics by problem solving methodology. This methodology presupposes that students can take some of the responsibility in their own learning. Okay, because this is more an empirical way to learn. Okay, students practically is based on students' explorations and at the moment to solve a problem. And the learning they discover at the moment they focus on this, it's very important. It's very important. It's a vital element of the curriculum, as we see over there in the presentation. So it provides students opportunities to use their knowledge, the knowledge they acquired in real life situations or activities. And this is connecting now with something that probably you start listening and is real situations, okay? Authentic situations or authentic problems. That's the name, okay? You probably will be listening a lot of this because it's an evolution. This problem solving methodology, now it's an evolution to this authentic situation. For example, students will get the total amount of something they buy if they go to the supermarket, and we will see more real activities, not like those situations we have in here that probably, yes, are considered probably real situations students will leave. But what happens if we want to give them the chance to do something real, something that they can see in their life, like, I don't know, probably calculate the money you will pay for the use of energy. Okay, I don't know, probably like that. And at the end, this converge in the significant learning. Want to say something?
Yes, or for example, changing money for a different kind of, let's go from bills to cents. Let's say 10 lempiras for in cents. So,
Okay,
so you're gonna engage them through real life situations.
exactly. And this is the idea. Move students not just to those paper store problems that we have been doing, and it's so good because those develop many competences too. But move these situations to something real. But it's so hard. To be honest, it's so hard because there are no many real situations, real life situations students can do that require simple addition. Okay, so let's see what happened with the problem solving methodology, and well, it responds to society needs. Second, because and it's something I think we feel. Okay, there's not a way, a connection between the contents we teach and the application they have in reality. But it's so hard to teach economics application. Don't know if here we have a counter. Don't remember if Tesla is a counter, or I think you have
Yes, it's true.
experience with this. And do you think will be so good? Don't know the name in English, honestly, but I will talk. Will be easy to teach students debe y haber in third grade?
Oh, in third grade. Oh my God.
Okay, you feel like, oh my God.
Es difícil.
It's still been difficult for us adults.
It is so difficult because you need a pure knowledge
You
for
need a
teach
lot of
about
prior
it.
knowledge, right? Yes.
Yeah.
And that's the problem. That curricula is not focused on this, right? A simple idea like this, debe y haber, wow. And I
Only
think
for the
that's
name. Solo con escuchar el nombre, usted le dice a un niño de primer grado, usted debe y haber, y lo perdimos, mister.
que debo y va a decir, ¿y qué hago?
¿Y qué es lo que, ajá, y a ver de dónde?
Es bien interesante, pero sí, es bien difícil. Yo quiero que entendamos el punto, que lo que se quiere hacer con esto de los problemas auténticos es darle un sentido real, no tan ficticio como los problemas que hacemos en papel. Bien difícil. De hecho, tengo conocimiento de 3 profesores que han estado trabajando, no 2 semanas, llevan ya 5 años y solo han podido descubrir 5 situaciones, prácticamente una situación por año, que pueden enfocarse en enseñar algo, como suma de decimales, resta de decimales, pero que es real. Es bien complicado. Okay, so problem solving hub becomes to means the rejoin of those contents and the application in paper situations, not probably in real life situation, but it creates in the students strategies that can use in different contexts or in different situations. And this is what this problem solving methodology, it's very important because it shows really the connections or let the students have this little connection. So George Polya, as you know, who's the creator of this methodology, works these based on next 4 steps. You probably will see more, but those are the 4 original steps. First one, understanding the problem, devise the plan, carry out the plan, and look back. We're gonna describe each of this one. For understanding the problem, what do we have in here? Some of the techniques he proposed. And as you can see, all of those are related with the comprehension of what you have over there. Some people will add some techniques here, like draw the situation, look for similar situation or analogies. There he is. Check if one strategy you apply another exercise works for this one, but that's more for next. So here we have some of the strategies that George Polya proposed at the moment to understand a problem. At the moment to devise a plan, some of the common techniques students use. Yes, and check, eliminate possibilities, consider special cases, use direct reasoning, solve an equation. Well, here you have many more ideas. And for example, here I will add like use the bar model, which is something you will do. Okay, you will try, I think. use formulas, solve simpler examples, think backwards, which probably helps here. And it's a not direct way to work. Normally, those are direct ways to work, but something you can do. It's like suppose the answer and then see how this will fit in the situation you have. Okay, but so hard to use this technique too. At a moment to carry out a plan. So here, students will apply the methodology they want to in order to solve the exercise. In this part, we focus in something that we call the OP, the operational planting. We focus here into solve this operational planting, and it's practically prove an hypothesis and then get a result. What happened when you get a result? So it's moment to look back and see if the answer you have really has a sense. For example, doesn't have any sense that if you make a subtraction of tens, get a result that is 100. It won't have any sense, right? And I'm saying this because it's too common. We study during the week multiplications, okay? Then at the end, you gave the students one story problem. They see the number 5, they see the number 4, they multiply 5 times 4, and they're supposed to get the answer because they don't like to read. So we need so many skills in here. It's a little bit hard. So does the answer makes any sense? You have to try to create the space to ask the students if the answer they got really respond to the exercise. And finally, another look back strategy could be check your result. It's so important if this fit in the situation. And as you know, many of the exercises fit in an OP, in an operational planting. And what we do is check if this equation really works for what we want. What happened with us and this problem solving? Okay. If we use this method, it's a little difficult, okay? To use this method, it's a little difficult because we normally will begin our lesson with a situation, okay? With a problematic situation, okay? We're gonna say it just like a situation. The problem is the surprises we will see during the procedure or during the process we teach, because probably we will see a student solve this one way or a student solve this in another faster way. But it depends a lot of the problem we choose from the beginning. Question, can math game be considered as a problem? What do you think? Yes or no? Can a math game be considered as a problem? For this, I think we must have clear what's a problem. We will talk about this in a few slides, but I think that you can tell me if this is or not a problem, can be considered like this. What do you think?
I think that there are some math games that could be considered as problems.
Not all of them, right?
Not all of them.
Okay, okay, I like the answer. I like the answer. It's true. Okay. Problems are test students in a natural way, and it ensures that students are genuinely interested to solve them. Okay, we have here a challenge, and we have to motivate students to solve problems. I mean, the students see a story problem. You can probably make a worksheet with 1, 2, 3, 4, 5 exercise addition, and then one story problem. They start to say story problem because they see this like something hard. And well, that's something we have to try to change. And this methodology is requesting us to do this. And finally, here a recommendation is make questions in an deductive form, and that way students will discover ideas to solve the problem. Don't do it in an inductive way, which is normally what we do. Okay, do it in a deductive way, like show them a regular example or a general example where they apply the rule, how the rule works, show some little examples, and students will probably find out the way to solve the situation they are, okay? The idea is not give the students the way to solve it immediately. No, let them explore a little bit the problem, let them suffer a little bit this math over there because they need it. They need it. They will discover a lot in this mode. So what happened with this in mathematics? Okay, problem solving is a human task. I think that everybody's looking for a solution of a determined situation in a determined moment of their life. I don't know, probably you are in the situation that you need a house, that you need a car, and then you start to looking for the way to get money. So is it useful for students? Yes, because it gave them the chance to be in one of those situations, not exactly in the same situation. We have to be realistic. And what we want to with this is develop critical thinking, as you say at many times in the other classes. Problem solving is a good model, or in this case, methodology to work like this. And especially here, that students work and with data. Okay, works with the manipulation of data, and well, that's what normally happens. Okay, in real life, do I have that enough money to buy a house? Do I have enough money to buy a car? Do I have enough money, or do I have uh, do I save some money for any situation? Okay, so this is something students start to explore over there. Not in that way, but in that sense. Problem solving is the ability to identify, solve problems by applying appropriate skills systematically. I'm gonna add something over there, and it's because um, the people who think more, okay, is adding one more part in here. It's not just solve, and it's not just identify. Okay, it's not solve and identify. No, it's create problems too. So we have here like three situations. With problem solving, what we want today is not just this, right? It's not just identify, solve. No, we want the students to create situations too. Open other areas of the curricula, and this is so important. I don't know if you ever hear about the curricula based on projects, okay, which is an interdisciplinary way to connect, for example, science with mathematics or social studies with science, and there's an interdisciplinary way to connect those, working based on project. That's happening in Spain, I think. It have been growing in those last decades from 20 um, from 2001, I think that it had to be growing a lot. And it's so hard to look for a project that connects math with science, for example, or math with Spanish or with language. It's so hard, but it's possible. It's possible. And at the end, if we work with project, especially you, that you have the chance, working not just mathematics, okay, as you're working with all the classes, it will be so good. And at the same time, I think you save a little bit of effort, um, because you will like evaluate two things or two classes with one just activity, with just one activity. Well, here we will, we're going with the last part of this one. And yes, I'm missing like 5 minutes. So we'll give you right now just the ideas, then one activity, another presentation. We'll give you the rest of time to work in an activity that is, it's already uploaded. It's the activity number 5. I was checking group number 5. I already checked everything. I already read and I already identified there is a link that connect yourself to a Jamboard. And it's a little bit related with this, okay? It's a little bit related. One part is related with this. The other one's related with the ABN, and the other one is related with the TWL methodology. So can we identify when something it's a problem, is considered a problem or not? Let's see. An important aspect of problem solving is realizing when is dealing with a problem situation and is working to transform into a well-defined problem. Sometimes we have different situations, but the classic problem, Maria goes, or Mary goes to the pulperia, she buys uh, 2 snacks. Each snack is $5. How much money does she spend? Does she spend? Okay, is this a problem or not? Well, we have to see if this works or not for what we want. It depends a lot of the context. Let's see what happened with this. Usually the term problems is used to refer to a situation where it's not immediately obvious how to reach the goal. So it's so hard. And this is something that Paul just proposed. Not immediately obvious how to reach the goal. So it means that students must think and look for the way to get it. In this case, I think that's better to call those like challenging situations, better than a problem. Because sometimes students hear problem, they start to focus in something that is wrong. And I don't know if you ever seen the meme that you have a math notebook and it's full of problems, and he kills itself, right? Because of that. No, we have to get or change that word for challenging situation. I think so. I don't know. We probably will change a little bit the idea of problems with this. Okay, with this I will conclude. Then we have the break from 5:30 to 5:45. Okay. So how is considered situation like a problem? We have three basic components. The first one is clearly defined initial situation. And well, we have here one interesting part, and it's that sometimes we have distractors. Are those part of the learning in a problem? Yes, they are needed sometimes. Not that in every problem or in every challenging situation you're gonna have a distractor. No, it's just something that you can add to be sure if your students are catching the main information. Clearly defined goal. That's related with the question. Normally in story problems, we have one, two, or three questions, and they work gradually. Okay, it's not that you're going to answer the third one, jumping the first and the second one. No, they have clearly defined the goal. Clearly defined set of resources that may be applicable or helping you to move from the initial to the goal. And well, here we have a little problem with this one because normally students, if we gave them the chance to explore, because this is very, I don't know if it's, we'll say in Spanish, esto es bastante empírico, okay, problem solving es bastante empírico, and it focuses not in just follow one way to solve it, okay, remember here, students explore and yeah, they need the resources. And we provide the resources. We teach them how to add, we teach them how to subtract and everything they need. What they do is focus in how these techniques they have will work, how they can apply it, okay? So to achieve the desired final goal, you're committing to use some of your own resources. And here is where we have the little situation I told you, the little problem. Students sometimes breaks apart or investigate their own, and well, this is one of the ideas of the problem solving or work based on project, that students find their resources, their ideas, their knowledge, and not just the one that professor or teacher gave, right? Is that they have the free to achieve this goal by the way they feel better. Okay, we're gonna conclude this activity, this presentation for the break. Okay, it's 5. Yes.
In an initial situation, you can use such examples.
Well, this is when you have a problem. When I say initial situation, I'm saying that if the problem really have all the information you need to answer it.
But exactly
all the information you need. There are some distractors sometimes in problems. Yeah, that's good, but not always the best way to teach or to use a problem, okay? But you have to provide them like the information. This example, here, have all the information you need to answer the problem, the question you have over there, which is the goal, right? How many miles did he run? Do you have the information to answer these? Yes, you have over there. Run 6 miles and 8 miles. Does he probably run some more? Okay, yeah, probably, but the information we have is this one. Okay.
Okay, thank you.
Welcome. Bien, entonces creo que sí, me pasé 2 minutitos y que volvemos a las 5:47.